Brad here with some stoichiometry. We're going to do mass problems this evening. First problem we're going to look at is a three-step mass problem. You read the question with me. How many grams of iron 3 oxide are produced when 20 grams of iron react with oxygen gas? First step you have to do is balance the equation. Put a 4 in front of the iron, a 3 in front of the oxygen, and a 2 in front of the iron 3 oxide. It's a balanced equation, and now you're ready to go on to some stoichiometry. In class, I like to teach using a road map. This is a technique which works for most of my students, where you put moles on the bottom and grams on the top, or liters if it's a mass volume problem. In this mass problem, I wrote 20 grams over the iron, and I put X grams over the iron 3 oxide to give us sort of a plan to actually get through the problem. We can't go from grams to grams without going into the realm of moles. So if you look, I've made an arrow going to moles, and then going from moles across to moles of iron 3 oxide, and then moles to grams. Each arrow represents a step that we need to take in order to solve this problem. That's how this roadmap works. So if we look at the first step in the process, we're going from grams of iron to moles of iron. When we do that, we need to actually take the molar mass of iron off the periodic table and put that on the bottom, so that way grams of iron cancels with grams, and we end up converting to moles. That completes our first step. The second step is to go from moles of iron to moles of the iron 3 oxide. This is where we use the mole ratio step that you guys learned previously. The 4 in front of the iron goes on the bottom because that's where moles of iron is, and where we're going, moles of iron 3 oxide, the 2 from the balanced equation goes on top, and you have that step correct. The third and final step is to convert moles back to grams for the iron 3 oxide. This allows us to reach our target. The balanced chemical equation gives us the actual pathway. Once we actually get the molar mass of the iron 3 oxide, we place that on top of the third conversion factor, moles of iron 3 oxide on the bottom, and ultimately all conversion factors are set up so they cross cancel, and we get to our desired result, which is the iron 3 oxide, in this case 28.6 grams. Our final answer. Thank you for listening. Keep working hard.